It has a diameter of over 100,000 light-years and is home to an estimated 200 billion stars. But what do we really know about our home galaxy, the Milky Way? Well, apparently you never stop learning, even on your own galactic doorstep. In fact, in recent months, experts have gathered a series of spectacular insights that shed a whole new light on the Milky Way. This even starts with a very fundamental point. After all, the latest data suggests that we have been categorizing the Milky Way all wrong this whole time. But that's not all. In the same breath, astronomers have also discovered a gigantic 16,000 light-year structure in our home galaxy and found out that the bizarre gravitational monster at its center has been through something that impressively demonstrates the primal forces of the cosmos. To get started, here's a little quiz question. Why is the Milky Way actually called the Milky Way? Well, the fact that our galactic home still has the word milk in its name is thanks to the ancient Greeks. According to an ancient myth, when we look at the starry night sky, we see nothing other than the spilled breast milk of the goddess Hera. A milky pattern that applies not only to our own galaxy but to all galaxies, after all. The ancient Greek root galaxias means nothing other than milk. But if we now detach ourselves from ancient mythology and instead take a look at the astronomical facts, we recognize that the supposed milk of the gods is, in fact, nothing more than star clusters interspersed with light and dark nebulae. However, since we are located in the middle of the Milky Way with our Earth, it's in the nature of things that this Milky Band, which rises in the southern sky on clear summer nights, by no means represents the whole but merely a small section of our galaxy. From our point of view, it's simply not possible to see the Milky Way in its entirety. Despite this, astronomers have, in the past, been able to draw a general picture of our home galaxy. The Milky Way is classified as a barred spiral galaxy with 5 enormous loose spiral arms, 2 of which we can see in the sky. Furthermore, the diameter of the Milky Way is estimated at 100,000 light-years. Although apart from its center, it is only 3,000 light-years thick. The thickness of the aforementioned center is about 16,000 light-years. The actual heart of our galaxy appears invisible to our earthly eyes due to the numerous dark clouds that put natural blinders on us with their interstellar matter. Despite all the visual barriers, it is now considered certain that a full-grown monster lurks at the core of the Milky Way. Sagittarius A*, a supermassive black hole with more than 4 million solar masses, resides there. Contrary to what you might think, this is not a galactic exception but rather the rule. In fact, experts now assume that almost every galaxy center is adorned by such a supermassive gravity monster. When it comes to the much smaller stellar black holes, which arise from collapsing stars, experts estimate that there are around 100 million of these bizarre formations in the Milky Way. As for the number of stars, astronomers' estimates sometimes differ significantly. While some believe that our home galaxy has only 100 billion stars, others suspect it's home to as many as 400 billion blazingly bright celestial bodies. Given data from the Kepler mission and other studies suggesting there are, on average, 1 to 2 planets per star, there could be between 100 to 800 billion planetary worlds in the Milky Way. But not every one of these planets resembles a cosmic twin of Earth, which is obvious. And yet, in 2022, researchers from Nottingham determined that as many as 36 advanced civilizations could have developed in our galactic home. The Milky Way, like the Earth and the Solar System, is not a cosmic loner but an integral part of much larger overarching structures. On the one hand, the Milky Way belongs to the Local Group, a galaxy cluster with about 35 members. On the other hand, the Local Group is itself part of the Virgo supercluster, which is, in turn, part of the Laniakea supercluster. However, a new map of the gravitational catchment areas in the local cosmos now suggests that we have been misplacing our galactic home all this time. It actually does not belong to the Laniakea supercluster but to the much larger Shapley supercluster. This means that almost 60% of the structures associated with the Milky Way flow toward the Shapley supercluster, compared to only 40% toward the Laniakea supercluster. Astronomers have also identified gigantic magnetic structures, over 16,000 light-years long, originating at the ends of the Milky Way's bar. Rising far above and below the plane of the galaxy, these filaments may be the result of overlapping stellar explosions, creating galactic winds. Finally, Sagittarius A* may have merged with another massive black hole in the distant past. This cosmic encounter likely occurred about 10 billion years ago, as part of a galaxy merger with the dwarf galaxy Gaia Enceladus. Such dynamic primal events underline the fascinating history of our home galaxy.